Go ahead and get this presentation started. My name is Lori Brown. I am here to present the SQL 2014 new features and enhancements. I work for a company called Integrated Services, and we're located in Dallas, Texas, and our company focuses on SQL Server development, BI, app dev, and then the SQLRX branch, which is the what I'm part of. And SQLRX focuses on SQL Server performance tuning and remote database administration. So if you have any performance problems with your SQL Server, or you need help with your maintenance and monitoring of your SQL servers, give me a call. I can help with those things. We'll move right on forward in this. What we're going to cover is the new and improved things that have been introduced in SQL 2014. Some of the cool things and new are In-Memory OLTP and buffer pool extension, and then improved. Some of the cool things that I like was the Cardinality Estimator has been improved, index rebuilds, incremental statistics. There's a lot of buzz about ColumnStore Indexes, and I also, as a DBA, kind of like the improvement they made to the resource governor. So we'll go through all of these things. And this is moving slower than I like. There, that's better. New stuff. So In-Memory OLTP, this is one of the cool new things that people are talking about. It's a lock-free, latch-free new way to store data in memory. It's not like pinning a table in memory. It's not like that old thing that we used to do. And it's designed to eliminate your locking delays. You're going to have less latching and locking, and it's really less made for high-volume insert workloads. It gives you a way to get around your locking and latching issues without having to put in partitioning, and because partitioning can require some code changes. And it can really improve your performance for some workloads, as you can imagine. It's good for stored procedures. You can have in-memory stored procs. And one thing of note, since this In-Memory OLTP is done through an in-memory file group, which you'll see in a minute, you can only have one file stream file group for memory-optimized tables or objects, but you can have multiple files, so you can still spread your files out all over the place if that's what you do. So I always like to kind of show where things are, both in GUI. I'm kind of a GUI-oriented person, but I like to also show the code, so you'll get that as you go through the presentation here. So in your you go to Management Studio, and you go to the properties of the database that you want to enable to use it. You click on your file groups page. Make sure I click on the right thing. And under your memory optimized data pane, you're going to add a file group just like you would add a regular file group. This one is going to be In-Memory OLTP. And you give it a name. I named mine memopt. Then you go back to your database page, and under the files page, you're gonna add a file to your database. I gave mine a lovely little logical name of test MO. Yeah. And it's going to be the file string data, and I give it access to the memopt file group that I just created. In a table, you create tables that are in-memory OLTP by specifying that memory optimized is on in your create clause, and this differentiates it from your regular disk-based table. With memory optimized equals on in the clause, that tells the in-memory OLTP engine to handle this table instead of the SQL database engine. So here's in-memory optimized equals on. A couple things have to be set: bucket count and durability. Bucket count should be 2 times the number of unique values in the column, so you really have to understand the data in the table so that you can set this value. And then the durability gets set, so you have bucket count, which, of course, I set mine to an arbitrary number, but and then durability. And here I've set it to schema and data. Schema and data means that you're in the durability means is going to be how the table or the object is going to be persisted in data. So schema and data is what it means. It's going to the schema and the data both are going to be recovered on server crash, and schema only means that just the schema. You might wonder how this is done. I did, and it's because if a server crashes and memory is flush, how is that put back into memory? And it's done by SQL writing changes actually to the T-log. And using checkpoint files, it'll read that data back into memory from the disk on recovery, so it pulls it back off a disk into memory. So when you're done creating your table, a DLL and a bunch of other files are created, and you can find them in your MS SQL Server data folder. And I listed the tasks that I found them on my machine. And you'll notice that there's a new XTP folder and a subfolder with a number, and that's the database ID from the database that the object was created in. So you've got XTP, and mine was database 5. Then on the files that are created, you've got 5, that's the database ID, and then you've got another long number here. That's actually the object ID of the table that was created, or the object. So it just gives you another way of tracking back to figuring out if you find that somewhere on a server that you're managing, you can track back and go figure out what objects are in-memory OLTP. So you, in indexes on the table, you can have up to 8 non-clustered indexes, but no clustered index. Indexes can be created on string columns, but only if you use a bind to or bin to correlation. And you can, of course, I wonder what all bin to correlations do I have, and you can find that by checking the function fn help correlations. That'll list all your correlations that you got. When your indexes are created, you need to be aware that you can't drop or modify the index, so you have to really plan well before you create. As a matter of fact, I figured out that you can't, you have to actually drop the entire table to be able to change anything on it. So there are 2 different types of indexes that you can create, hash index and range index. And they're going to be more or less covering indexes, so it's going to contain all the columns in the table. The hash index is what I've got listed here. It's best to use for joins that are going to be equijoins or equal. In range, of course, is what it implies, things that's looking for a range of values or greater than or less than operators. For in-memory OLT stored procedures, they're otherwise called datably compiled stored procedures, and those also use the in-memory OLTP engine. That in-memory OLTP is a big word to constantly say. These stored procs can only access memory-optimized tables. And when you get done creating one, and I'll show you code here in just a minute, it's very much like creating an in-memory OLTP. It creates the same types of objects and whatnot. So here's the code to create a stored proc that is in-memory OLTP. I created one on for new road races. I like to fancy myself as a somewhat a runner. I'm not very fast, but so road races. And mine is really simple in that it just adds values to the road races table that I just made. But the kicker that tells it that it's going to be in-memory OLTP is the native compilation. You execute the stored procedure just like you would any other. Execute new road race, and I went and put values in there: 5K, 10K, half marathon, full marathon, and ultra. No, I've not done most of those. Here are the results. I just wanted to kind of show that how do you get data out of an in-memory OLTP just like you would any other. However, there are limitations, and there is T-SQL that are not supported by in-memory OLTP. You can find them at the MSDN link here that I've given. And by the way, if you download the presentation, you're going to get all the code and the links that I've got and provided. I like to make sure people can have access to that. Buffer pool extensions. This is a way to use SSD disks as non-volatile RAM instead of memory. It reduces your latency. SSD is faster. It stores clean pages. So there's no risk of data loss, and it'll give you faster access to data because it's on faster disk. It can provide some pretty good performance gains for read-heavy. So you have to know your workload, read-heavy OLTP type workloads. However, I've seen some warnings about using SSD on a SAN, mostly because it's expensive. And I've seen some comments that it can actually, SSD on a SAN can be worse performance. Not sure about that. Maybe it's how it's set up. But you enable it by doing an alter server statement, turn on buffer pool extensions. I'm going to tell it where my buffer pool extension file is going to be. This will be on an SSD disk, and I'm going to give it the size. Delayed durability is a neat new way to defer the acknowledgement of your transaction log records that are going to be written to disk. So the transaction can go on and they won't be waiting, and SQL is going to assume that the log record is going to be written. You know, those ACID rules that we've all learned about and lived with all this time for a relational database. ACID stands for atomicity, consistency, isolation, and durability. There's durability in there. Those rules guarantee that when a transaction is committed, it stays committed. And when you allow delayed durability, basically you're removing the D out of the ACID rules. So with ACID, durability is achieved through write-ahead logging, and that means that transactions are written to disk before the transaction is complete, so that makes it durable. With delayed durability enabled, you're going to trade durability for performance, and it does that by using a piece of the log buffer. It uses a 60 KB piece of the log buffer, and when that 60 KB block is full, it's going to flush that piece to the disk. So that's where there's the risk of data loss. You can set delayed durability at several levels, at the database level overall, at the individual transaction level, or in natively compiled procedures, or in-memory OLTP at the proc level. This is something you would enable if your transaction log is a bottleneck and you can withstand the possibility of some type of data loss. And you would know your transaction log is a bottleneck because you would see a lot of high write log weights. So you might think, well, gosh, how am I going to know? You know, I need to take my server down. Something needs to happen. I need to make sure that everything has been written to disk. How can I make sure that happens? Well, you execute sys sp flush log, and that'll flush everything to disk. So you set it at the database level. Like I say, I like to show it in all ways possible. You enable database, delayed durability. Set it to disable allowed or force. And here it is in the GUI. So allowed is what you would think. It'll allow anybody that can use delayed durability, it will. Force means that all transactions will use it. That can use it will, I'm sorry. With the allowed, I want to step back 1 second. I made myself a note. If you have transactions that have delayed durability set in them, say like in a stored procedure or something, and you begin a full transaction, like a name transaction, and you call a delayed durability statement within that. With the transaction, that is a fully durable transaction, and so the delayed durability will actually force any delayed transaction. It's going to actually force any delayed stuff to get flushed to disk when you have a fully durable transaction. So just so you know, when you wrap it inside a fully durable with a delayed, I think the durable is going to override. And the last setting, disabled, means that it's disabled at the database level. Any transaction that's going to try and use delayed durability is going to be ignored. You set it at the transaction level. Of course, you would do a begin transaction, and when you commit it, you're going to tell it delayed durability is on. And in an in-memory OLTP stored procedure, you add that to the begin atomic block. I meant to show it to you before, and I forgot, but it's in this create store proc begin atomic with delayed durability on. Backup encryption. This is kind of nice. It's been introduced to allowed is to to encrypt backups without being forced to encrypt the entire database, which is kind of nice. It supports a bunch of different encryption algorithms, including Advanced Encryption Standard, or AES 128, 192, 256, and triple DES. You can also compress the encrypted backup, which is nice as well. Be aware that encryption will cause a bit higher CPU utilization, so you need to make sure that your CPUs have enough capacity to be able to handle the increased utilization while backups are occurring. And so how do you set it up? I just wanted to show you. You have to set up a master key, of course, when you're going to encrypt. So I set up my master key with my lovely, very secure password. And then I'm going to set up a certificate or asymmetric key. And truthfully, you know, I could only find examples with a certificate and not with an asymmetric key. That was kind of interesting to me. And then you back up your database, just like anything else, but you turn encryption on. You tell it which algorithm you want to use, and you name your certificate that you're going to use. New permissions. These are some neat things that are designed to allow you know, better management for most DBAs, having to set up users and stuff. So instead of us doing so much work, there's some ways that we can give some new permissions. It's kind of some blanket permission. We're going to allow logins to connect to any database, either the ones that are there now or the ones that are coming in later. So you create new databases, that user is going to be able to connect to them without you having to go in and give them explicit access. Impersonate any login. This gives a login the ability to impersonate any other login. And you can also use that to deny impersonation as well. So it kind of goes sorry, I was looking at one thing. Somebody sent in a question. I'll answer that in a little bit. Improved things that have come in. There's a bigger list of those. Hardware limitations has been raised or improved. Enterprise Edition supports up to 640 cores and 4 terabytes of memory. Gosh, I've never seen 640 cores. That would be pretty cool to see. And I think I've only seen up to 1 terabyte of memory. So systems that have that would be awesome. Standard Edition, instead of stopping at 64 gig worth of memory that it could access, now it accesses up to 128 gig of memory. That's nice. Resource Governor has been enhanced. I like this as a DBA. It's pretty cool. It'll now let you set constraints on your physical I/O operations, and it throttles your I/O by controlling the number of I/Os that are sent to the disk subsystem, and this can be either reads or writes. And it's set by setting the max outstanding I/O per volume for the resource governor itself in minutes. And then you can create a resource pool, which I created a little one, pool admin, and I gave them a min and a max. So min 20, max 100, and anyway, this is kind of if I use these in conjunction, this probably wouldn't be so hot, but I just wanted to kind of show you how it's set. ColumnStore Indexes. This is one of the new kind of buzz things, and it's really used for improving performance in data warehouses. It's really good for the batch processing type of operations and read-only queries that use really large data sets. Any tables that are bulk loaded are really good candidates to have ColumnStore indexes. It stores data, obviously, in a columnar way, and it uses compression to reduce the amount of I/O on your disk when it's used. So each column of data is actually separated into its own segment, in case you haven't seen how this works. The segments are organized into row groups. The row groups can contain, about 1 million rows. And if a table exceeds that amount, SQL is going to wake up and create more row groups, and it'll break the column segments across them. There's a thing called the and performs that move if the condition is correct. And when it saves the ColumnStore index to disk, it compresses the data in the segments, and as a result, it achieves a higher compression rate than regular indexes. So a higher compression rate, smaller, equals better performance, since compressed data is smaller and faster and fits more in memory. According to good old Microsoft documentation, they say, use the ColumnStore index to achieve up to 10 times query performance gains over traditional row-oriented storage and up to 7 times data compression over the uncompressed data size. As always, you need to be sure to realize that your mileage is going to kind of vary. And that's because the compression rate in your performance is based on because it's based on the values that are in the column. So you have big values in your column, you're not going to get as good compression. One other thing to note is that with the ColumnStore indexes being compressed, it's going to hold more data in memory. So you need to make sure you have plenty of memory so you can hold as much if you need. And the last thing I noticed about that is that if you have queries that run against these tables that have ColumnStore indexes, and there's a lot of updates that are going to happen to it, those advantages that you make sure you know your workload really well. There are a bunch of limitations for ColumnStore indexes. I've gone ahead and listed them here because very handily they fit on my page. But I highlighted the things that have been enhanced. So are enhanced. They're now updatable. You used to have to drop and rebuild them to update them. And they now support clustered indexes. The weird thing about it, even though they support clustered indexes, they don't. The clustered indexes for our ColumnStore indexes are not actually in what we would think of as a traditional clustered index ABC 1, 2, 3 type of order, because it can't be specified to be ascending or descending. The other expansion that's been done to ColumnStore is that it's been expanded to more data types. So I've listed the exceptions rather than the rules because now there's more rules than there are exceptions. And it supports all the regular joins, and I listed a bunch of them in the bottom. So to create a ColumnStore index, you're going to go to your database, your table, your indexes, new index, and you're going to select the type of ColumnStore index that you want to create. And in my case, I went ahead and created a non-clustered ColumnStore index. And in your new index dialog, it's just like any other. You're going to give it a name and add your columns. So, of course, my running routes table got it again. So here it is in code. Once again, my running routes. And I created a clustered index on the route ID, and then I created a ColumnStore index on the rest of the columns. And part of the reason I did that is I wanted to show you too that you can have both regular and ColumnStore indexes on a table. For the Cardinality Estimator, this has been redesigned to make better cost-based decisions on your table and index cardinality. So when you have SQL 2014, it's automatically enabled for your new databases, but it's not for when you upgrade or migrate a database to SQL 2014. That's in a different compatibility level. So if you leave it in the old compatibility level, it won't be enabled. We have already noticed that there are times, and I'm sure you may have, if you've tried to think about using the if you've had SQL 2014 and you've noticed some things haven't run as well, you may have looked for this. In other words, there's people that are complaining about that the new estimator is actually causing some queries to run slow. So you really need to test very carefully in SQL 2014. And if you find that you're on 2014 and suddenly things aren't running so well, go ahead and put your database in an older compatibility level, maybe 2012, and see if the issue will resolve itself. There are some examples that I found in MSDN that I wanted to kind of talk about that would give you an idea of the improvements that have happened to the Cardinality Estimator. So in the first one, we're going to get some information about sales from 12/19/2013. And in this example, for instance, the issue here is that statistics were last updated on 12/18, so the day before the day I'm querying. So the stats were last updated on 12/18/2013. So the old Cardinality Estimator would think that the value 12/19/2013 does not exist, since the date is greater than the max date that the statistics contain, and those haven't been updated yet. The new estimator assumes that the values exist, and it uses the average cardinality for each value in the column, even if statistics have not been updated yet. So it's going to assume that there's a reason that you're asking for that. In the second example, I'm going to get some price information about Honda Civics. The old Cardinality Estimator assumes that the values in the make and the model columns are independent of each other, even though they're in the same table. That's kind of interesting. And it may estimate too low, the number of records that have come back, and it may estimate a little bit too low. So now the Cardinality Estimator assumes that the make and model columns, if they're in the same table, have some type of correlation, and it's going to estimate closer to the actual number of records that's going to be returned. And then the third one, where I'm going to get information about the sales returns for toys on 12/19, the old Cardinality Estimator assumes that the predicate filters of type from the sales table and date from the returns table, it actually assumes, even though they're from different tables, it assumes they're correlated, which is interesting again, and it'll estimate too high on the number of records that will return. So in the new estimator, it assumes that they're in different tables. They might not actually be correlated, so it's going to estimate a little bit lower to the actual numbers that are going to meet that filter criteria. So those are some examples I found of how it's been enhanced. Indexed rebuilds. They've given us the wait at low priority option, and this has to be done. Wait at low priority can only be set when index rebuilds are done online. Online has to be on, which is an enterprise feature. You set your wait at low priority, and then you set your duration, max duration in minutes, and then you're going to set the abort after wait, and that is what's going to happen after the max duration time is expired. You're going to tell it what's going to happen afterwards. So in mine, I've set it for example, I've set it for 10 minutes, and I've told it that after that 10 minutes, I'm going to kill my own index rebuild. So if I'm blocking things, I'm going to kill myself. That's a little bit violent, isn't it? But you've got an abort after wait. You've got 3 different options to set: none, self, and blockers. And none, I'm just going to keep on waiting indefinitely. Self is, like I said, I'm going to kill myself to give way to the users. And if something is blocking me, I'm going to kill off all users that are blocking me instead. Oh, sorry, that meant for blockers. Always on availability groups. This has been enhanced to allow you to now have up to 8 secondary replicas instead of 4. The other enhancement that we found is that if the primary goes offline because of like a dropped network connection or any other issues in the secondaries in the availability group don't go offline immediately. They'll now stay online so that your queries that are running on your secondary replicas can be run. If you're interested in how to set up always-on availability groups and how to step-by-step how to set them up and whatnot, one of my team did a really nice presentation, and we've recorded that, and that can be found on GoToWebinar. We've got a recording of it, and I really encourage you to go visit it. It's about a 30-minute presentation, and Ginger did a really good job with that. Incremental statistics. That's been enhanced to allow stats creation by partition. So when you set incremental option to on in your create stats statement. So now, as administrators, when we upgrade statistics, we can tell SQL exactly which partition we want it to update. And so as an example, I went ahead and created some partitions and some statistics. So I created a partition based on date on mine, so 2013, 2014, 2015, of course, on my running routes table. So I created my partition scheme, and I created my table and partitioned it on the race date. So when I created statistics, created my statistics on race date, and I told it incremental is on. So now when I tell it to update statistics, because old data is really not what I want to update, I'm really more interested in new, so I'm going to tell it to update the partitions 2 and 3. So this would be partition 1, this would be partition 2, see if you can read that or not, and this would be partition 3. Ooh, that's not bad. So in my case, I've told it to update partition 2 and 3. System views have been changed. Don't you love it when even service packs can change system views? But I found a few that have been changed. XML indexes now has 3 new columns: index type, a description for that type, and the path ID. ColumnStore row groups gives you clustered ColumnStore index information. So it'll tell you which row groups have a lot of deleted rows, and it should be built. So you can use that for maintenance purposes. And Sys database now has 3 new columns. So you can tell which statistics we're creating with incremental on, query store is on, and resource pool ID. In one dynamic management view that I liked, and it is used, the DM exec query profiles. It monitors your actual execution plan in real time. So, but you have to enable your capture by setting your statistics profile on. And here I went ahead and want to show my plan in XML. And then I want to run a query. Of course, I run from my running routes table. And in a different query window, if I want to see those query execution plan in real time, I'm going to go to another query window, and I'm going to run this query. And it's going to show me what's going on real time. I can sit there and refresh it and see the execution plan. So I thought that was pretty cool. Then backup and restore. Backup and restore has been enhanced to give you the ability to back up to a URL right from Management Studio. In the past, it was only supported by using T-SQL. You could back up to a URL using that, but now you can use it in the GUI. I'm kind of a GUI-oriented person, and I like that. And it's available also in your regular backup tasks that are in your maintenance plan. And here it is, your URL that you're going to back up to. You need to learn to draw better. And so we're done. Those are all the things that I could find that I thought were really cool to show off to everybody, the new and improved things in SQL 2014. There's a lot of them. You know, just the word of caution. If you know, you think this is really cool, I'm going to go ahead and enable this. Please, please, please test very carefully before you throw that into your production environment. Otherwise, well, I don't know. Maybe you'll call me and tell me you need some help. But I've really got to caution you. Some of them have some serious performance implications if they're not used correctly. So be careful what you do. Test and have lots of fun with them. I'm going to go and look for question, sorry. Any performance improvement when using delay, durability, in simple recovery mode? And I don't know if there's right at this point in time, if there's a performance improvement for simple recovery. If there is, I would imagine that if your transaction log is a bottleneck, that when you enable delayed durability, there's going to be a performance improvement regardless of if it's in full or simple, because transactions still have to be written to the log. Is the last feature the DMF enterprise only? I'm going to back up and go see which one that was. Query plan running. No, I don't think so. The exec query profiles, I don't think that's a enterprise only. I would have notated that in my notes. And then I have another person who's asked what type of SSD disk would recommend to use if SAN attached SSD has an issue. I don't have a preference of SSD disk, and to the person who's asked this, I'm going to consult with my architect and see if there is a preference of a specific type of disk. I don't have a specific SSD disk recommendation. Just use SSD, but make sure it's configured properly. One of the things we found with SSD that if they're not set up properly, the SSD can have problems just like regular disks. So the person who asked this, I'm going to check on that, and I'll likely get back to you about that. So we'll go ahead and wrap this up. I've gone ahead and put our contact information up. I'm Lori Brown. My email address, Ginger Keys, and Dan Hooper, who is our VP of Sales. We've got our contact information up there. You can follow me on Twitter. I am SQL Superstar. We are on the web. We have a blog, which I'll probably start putting some information about some of these subjects up on our blog over time. We're on Twitter. We post new blog posts and information about some of the upcoming things that we're doing on our blog and Twitter and Facebook as well. So you can find us all over the place. Oh, and gosh, we're on LinkedIn, and I didn't list that. I'll have to put that in the next one. So last of all, we always want to know what we can do for you. I'd like to help you out if at all possible. We have a free, what we call a vital signs review, and it's kind of a health check type of review, which one of us will contact you and, if you want it, and take a look at your SQL environment and see if we can find any problems, right off the top of our head, and we'll walk you through that for complete free. So give us a call or email us if you'd like that. And as always, let us know if you have other topics that you'd like us to cover in another webinar. We'd be happy to do that. So that's it. Thank you for attending,